Hey, what's up, ladies and gentlemen? Welcome back to the Incredible Academics YouTube channel. Guys, listen, today what we're going to be covering is slightly different. It's another type of sequences / series. So, obviously, for us to be able to understand geometric series, we need to first make sure that we deal with geometric sequence in depth, the same way we did with arithmetic sequences, arithmetic series. Remember what we started with, right? Because the foundation for arithmetic series, that is arithmetic sequence. Okay, that is why in grade 11 you guys did arithmetic sequences extensively, because they knew they would have to then extend from that and then introduce what we call arithmetic series. I don't know why they didn't cover geometric sequences in grade 11, or maybe it was part of the syllabus. Well, I don't know, but I just feel like there wasn't that much of geometric sequences in grade 11. But anyway, look, this is what we're going to be discussing today: geometric sequences. And I'm going to give a quick example for arithmetic. Remember with arithmetic, if you've got 2, 7, 12, 17, you can already see that the number that I'm actually adding from 2 to 7 is 5. From 7 to 12 is still 5. From 12 to 7 it's still 5. So the D is basically what? 5. That's the constant difference. So now look, when you're dealing with the with geometric sequences, there's no constant D, but there is something which is constant, right? We call it a ratio. Okay, because with geometric series, what you're going to have is you're going to have 2, and then 4, and then 8, and then 16, 32. So everything keeps on doubling, right? And immediately when you say doubling, that means you multiply by what? By 2. So now let's check what is the ratio. Here we don't find the differences between the terms, we find the ratio. So we're going to say, okay, fine, let's check 4 divided by 2 and 16 divided by 8. These are just consecutive terms. Also 8 divided by 4. Okay, and what answer are you getting? 2 here. This is also 2. This is also 2. So you can see this, there's a constant ratio, right? Constant ratio of 2. And the constant ratio is the constant ratio is denoted as R, right? So R is equal to 2, right? So now that means that whenever you're given a sequence, you don't know whether it's geometric, you don't know whether it's arithmetic, you don't know whether it's quadratic. You need to run these tests, and these tests are different, right? But for you to figure out that a sequence is geometric, then you must have a constant ratio. And if it's arithmetic, there must be a constant difference. And if it's quadratic, there must be a constant difference, right, by the second differences, right? Yes, so that's quadratic. So but when we're dealing with geometric, we have a constant ratio. And another example of a geometric sequence, so let's say this is let's say this is 8, becomes 4, becomes 2, becomes 1, becomes 1 over 2, becomes 1 over what? 4. So you can see that this time around we're not expanding. We're not expanding, sorry about that. So you can see from 8 we went to 4, 4 went to 2, 2 went to 1. So now let's check what is the constant ratio. Remember the golden rule. You take the term, this is 3, 4, you take the term at the highest position, and then you divide by the term that precedes it. Okay, so you can see that 4 needs to be divided by what? By 8, right? Because 8 precedes 4. But we can't divide 4 by 2 because 2 succeeds 4. Do you understand? So we're always going to say, okay, the one that's at the highest position divided by the one just before the one that's at the highest position. So 4 over 2, 8, right? 4 over 8, this and that. 2 over 4, 1 over 2, right? 1 over 2, and then 1 over 4 divided by 1 over 2, so on and so forth. And you will realize that throughout your answer is going to be 1 over 2. Okay, that is the constant ratio. And this is very interesting because if you're given, let's go back to the sequence over here. Once we figured out what the constant ratio is, we know that, okay, we can find the next 3 terms. To find the next 3 terms, you simply take the last term, which is 32, multiplied by the r. And the r in this case is given by what? 2. Then you get your 64. 64 multiplied by what? By 2 again. You keep on multiplying by 2 to get the next term. The same way we had to keep on adding the 5 to get the next term. This time around we don't add, but we do what? We multiply. So same goes for this one. To get the next term, you simply multiply by the constant ratio. So you all already know that it always boils down to the what we call the general term. Okay, so a general term for a geometric sequence, it's given by that Tn is equals to a, which is the first term, r to the exponent n minus 1, and you guys know what the r is, right? So a is equals to the first term of the sequence. So this is the same even for arithmetic sequences, even for quadratic sequences, it's all the same. All right, so and then r is simply the constant ratio. Okay, so now we know what these variables stand for. So now what we're going to do is we're going to say, okay, that is fine, but now remember we dealt with what? We dealt with 2, 4, 8, 16 and 32. Right, now what is the general term for this sequence? First thing you're going to do is, okay, you guys, okay, let's check if this is actually geometric. And you guys have already seen, right, from the calculations that we've done, that r is actually 2. Okay, that is the constant ratio, and a is what? Also 2, right? So Tn is going to be equal to what? 2 times 2 to the exponent n minus 1. And laws of exponents, if you've got powers of the same base, what do you do to the exponents? Remember, there's a 1 over there, so that means that's our Tn. Tn is equal to 2 to the n. Now, for this Tn, we can generate a term at any position. All right, give me any position, then I'll be able to find that term. Because if you say, okay, sir, please find me term number 15. I'm simply going to, okay, T15 is equal to 2 to the exponent 15. If it's T 50, I'm just going to say 2 to the exponent 50. Right. So that's how you find the corresponding term. Okay. So obviously, sometimes you are going to be given what we call, you're going to be given the actual value for the term, and you're going to be asked to find the position, right? So you must be on the lookout for, those type of questions. So in the coming video, I'm just going to look up some of the questions that are based on geometric sequences. We'll tackle that, and once we're done with that, then we'll look into geometric geometric series, but we must have already done some questions together in order for us to do that. So we've come to the end of the video, and I hope you guys have enjoyed it. Don't forget to like and subscribe if you want to be part of the family. That's it for now.